Hi, gentlemen, ladies. Good afternoon, good morning, good evening, I guess, somewhere in the part of the world. Welcome to our latest quarantine edition webinar today. As I was talking to my friends here on the panel, somebody's in the UK, somebody's in Bombay, and the weather is awesome. And we're sitting at home. So I think it's a reverse trajectory of our timelines, but such is life. And I think what all of us, I guess, have learned to kind of live with is the fact that embrace the current moment. And so today, the 21st of April, is a subject on zinc facades, which is one of a very interesting topic. My name is Amit Malhotra. I am the co-founder of WFM Media along with Ahad and Zach, and he will take the forward in terms of introduction of the speakers and the Q&A session. Thank you. Ahad, over to you.
Hi. Thank you, Amit. Good afternoon, good evening, good morning for some people. Thank you very much for attending today's webinar. So as Amit said, today's webinar subject is on zinc facades. Not exactly zinc, probably the second half is zinc. We have an architect who probably be talking much more than zinc. I'll just give you a quick overview of today's session. So we have the introduction first, followed by a presentation by architect Sandip Agarwal, who's the director at Practice Design, followed by a presentation by Jonathan Lowy, who's the operational marketing manager at VM Zinc's UK branch. Just to give you an overview, Sandip would be talking about Monobloc in Urban Mosaic. He would be covering mixed-use development challenges, inflection point in retail design, and the RAP story of Zinc, which I believe is a case study of a project he's done in Bhubaneswar. Jonathan will be talking on architectural zinc in building envelopes, giving you a complete overview from zinc production, sustainability, aesthetics, different kinds of systems, performance, and budget constraints. Sorry, procurement and budget. Just to give you a quick overview about our speakers, so Sandip is the founder director of Practice Design. He's one of the smart architects here in India, envelope driven, so most of his projects have fancy facades. You'll be hearing from him later after I finish. So he's one of the interesting architects here in India. Jonathan is the operational marketing manager at VM Building Solutions. VM Building Solutions are the company which promotes the brand VM Zinc, which is popularly known in India. So Jonathan has over 23 years of experience. So Jonathan is speaking to us today from his home in the UK. So these are our two presenters for today. I'll go straight into the topic, which is on Monobloc and Urban Mosaic, which will be presented by Sandip Agarwal. Let me give the control to Sandip. Just to give you an overview of today, so we've got roughly around 650 odd registrations for today's webinar, which is excellent. We've already having 260 odd people joined us, so we will have more joining us in the next 5 to 10 minutes. But thank you all those who have been able to take time out. This is webinar number 6 in the WFM Media platform. I hope you enjoyed today's webinar. Me and Jonathan will be switching off our cameras now, and over to you, Sandip, to take over.
So good afternoon, friends, and I will also kind of go to my presentation mode. Try to switch off the camera. And good afternoon, friends, and good morning, good evening, wherever you are in the world. There is a new story emerging about traditional mall, and it is one of resurgence and reinvention. And that's why there is an inflection point in the retail mall design. And today's presentation, we will cover the new retail centers of the future in terms of design, as well as we will cover one of the projects that we have done, which is the Monobloc, and also we will look at how we use zinc in the facade as one of the major, one of the most challenging facade that we have done in India till date. So why is there an inflection point in terms of design? Why do we actually need to rethink the mall? Because the consumers today are looking for a new experience that is beyond the traditional shopping. The Gen Z, they actually go to the mall not essentially to only buy, but for a new experience, to learn something, as well as to socialize and to be with friends. So traditional use of a mall is being changed into more like a social center. The second is e-commerce, which is, there is an e-commerce revolution around the globe at the moment. There is very comfortable shopping which is possible through the e-commerce platforms. It's more sustainable. It's more easier. You don't have to drive down. You don't actually have greenhouse emissions when you do e-commerce. So it's a much more easier way of shopping. And then we have the digital technology. It makes it easier, far more easier to use e-commerce today. And also the digital being more immersive, it's the whole point of seeking external experience is reducing around the globe. And why do consumers look for
Sandip, we lost your audio. I'm not able to hear you. Can you just check if your audio is fine?
parasol in Spain? You can see that it's very little bit of retail. There is a market there, but it's more of a museum and it's more of a social space. So the city meets, greets, and performs in metropole. So the city interacts. It's like a white space in the city where the city meets its residents. And a similar example you can see in Seoul, which is a floating garden. So these are essentially not retail spaces, but social spaces, and how social spaces actually are more successful than retail spaces. But the idea now is to can we actually bring the same elements of social spaces which are successful throughout the world, like the New York Highland and everything, into a mall? And so what can be the future of the retail mall? This is how we used to design malls earlier, right? I mean, you used to see malls all across the country in smaller towns, B towns, looking like this. And these are no longer, this is not the model that we can follow. And what happens in the mall today is we have got the hypermart, and in the ground floor, we have got the anchors. The first and the second floors mostly is made up of MSUs and vanillas. And the third floor is the multiplex and the food court. But if you actually visit a mall today, you will see people having maximum amount of fun on the third floor, where the movies are, where the food courts are, and where the games are. So the whole idea then is can we actually turn it upside down? In today's scenario, so if I compare today's scenario with the future retail mall, today's scenario, the mall is enclosed. It has got shopping outlets, anchors, MSUs, vanillas, and the food courts and entertainment and movies right at the top. But the future mall, because are going to become the destination centers and also will behave like the town centers, will need to be seamless and sensibly open air. There will be more engaging shopping experience and dining experience, and those will be the place to spend quality time with your friends and family. So a big aspect of it would be that bringing performing arts along with the movies to the malls. So what are the interventions that an architect needs to bring in terms of design? One is the typology. The mall becomes a more porous public space. You actually don't enter through one little gate and get checked and get in. It's more porous. You can come in from anywhere. It's pedestrian as well as cycle, as well as all different kind of mode friendly. It is seamless and open air development. We need to reduce the air condition dependency on the malls, because if we are actually going to increase the social spaces, the developers will not be able to bear the burden of the larger air conditioned space. Food and entertainment will take the front seat. If you talk to the consumers today, 50% of decision to go to a mall and which mall depends upon where do you want to eat. And there will be a convergence of cinemas and performing arts. We do see some convergence happening in terms of laughter clubs and comedy circuits, but we haven't seen a larger performing arts getting built into the mall yet. So it may not be a mall, but it will become a large social town center is what we can call it. There will need to be larger flexible spaces for the pop-up and experimental food stores and anything which is unpredictable, which you can't think of today. And some examples where malls have opened up, like the Central Festival Mall in Bangkok, which is largely green. The common areas are non-air conditioned. It's very food centric, and you can actually ride in with your cycle inside. One such example in India is the City Center One Mall, designed by Charles Correa in Salt Lake, Calcutta. There is a large central kund which works very well as a social space right at the entrance of the mall. And shopping is incidental, but the mall is doing very well because that's the place to go to in the evening, because Salt Lake, being a satellite town, otherwise didn't have any other large public space or a congregation space. So there is one aspect is to actually design malls to bring in a lot of crowd by integrating the things that we discussed a few minutes back. But the other one is that we also need, the retailers will need to also create an experience within their shop. So if it's, say, a chocolate shop, it will need to be a working factory. It can have an educational area. It can engage the visitors by giving cooking classes maybe in the afternoon when there is less amount of traffic in the mall. And similarly, if it's a beer house, you can actually understand and witness a brewing process. So they will become more interactive and not merely a selling point. So the future retail model will actually have dining on the ground floor. It will have smart parking. Parking currently, other than in Bombay and Delhi, are a big challenge, because Bombay and Delhi, the construction cost is not really a big factor when we design a mall. But when we work in these cities of India, the parking cost adds on a huge cost to the construction of the mall. So the idea is actually, if we can segregate the parking completely, also we need to leave a large plaza with flexible spaces for pop-up, for Diwali, for Christmas, so that all the festivals can be celebrated in the mall itself. So what are the 5 strategies for reinventing the retail center? One, as we discussed, we need to design for experience per square foot. It's no longer going to be the size of the mall. It is going to be what is the experience at the mall. So we need to make sure that we remove the conventional big box retailers in favor of flex spaces, public gathering zones, and other programmable public-private areas. The second is we mix it up. So one is we will have shopping, music, food, which we are used to, but also we need to add schools, and because that will health clinics and schools, that will make it more integrated and more useful for mixed-use communities. The third aspect is to break down the walls. So the malls will become much more fragmented. It will not be one single box with one single entry. We need to make it more transparent and permeable, so that you can actually go to a single part of the mall which you really like, and not really roam around the entire 4 or 5 lakh square feet and to socialize. The connectivity has to improve. The location of the mall is very, very important, because we need to encourage multimodal connections, and that prioritizes pedestrians and cyclists. And we need to create a tapestry of third spaces or third places where people can connect and gather, supporting the retail center as a civic destination. This is one of the projects that we are doing now. It is an old warehouse where we are reinventing and reimagining the mall completely. What we have is food right on the entrance and right sprinkled throughout the project. You can see the main spine, the central spine going in. I may not be able to share a lot of images of this project because it's right now on the drawing boards. And that brings us to one of the project that we did in Bhubaneswar. Although it's not based on the new model that we just discussed, it is the water-filled site that you see right in the center of this picture was our site. And if you compare it to the surrounding architecture, you will see what a large monoblock it is compared to all the small little buildings, residential buildings all surrounding it. It's based right at the Cuttack Puri highway with the railway line right behind it. So it was nicely located in a heavy traffic area. The highway between Bhubaneswar and Cuttack gets a fairly good amount of traffic. And surrounding it was all residential, upmarket residential, as well as some commercial along the street. The challenge was the program, because it was a mixed-use development. Of course, the parking was taken care of in the basement, but we had a large footprint of the mall. The mall itself was around 8 million square feet. The entire project was around 8 million square feet, but we had the mall itself taking on the ground first and second. With the offices, the office blocks were very tiny. They were around 275 to 375 square feet each, while the mall plates were around 1,20,000 square feet each. So the challenge for us was, how do we actually integrate both these two, and as well as get light and ventilation to the small office blocks. So the distribution was that for the first 3 floors, like a traditional mall that we had discussed earlier, it was all anchors and MSU vanillas. Above that was cinema, and above that were offices. That's the scale. So we were fortunate that we were able to carve out a nice green large plaza with a stage. The number 11 there is the stage, where they actually have a lot of performances now. It's a Blackstone-owned mall at the moment. Initially initiated by 4. The offices are tiny. They are like 275 square feet each, but each one of them has a terrace. To get light and ventilation in each one of them, we actually exploded it up completely as a step terrace, so that we were able to increase the overall perimeter and overall get good amount of natural light into the offices. So that's a picture which actually shows the completed project on the office side. So you can see the office and the green plaza below. Which brings us to the wrap, which was the highlight of the project. So we actually wanted to do a neutral box at that moment of time, and we wanted to create awe beyond a well-detailed box. So for the awe, we actually went ahead and designed a wrap which was very bright. And initially, these were the first sketches that we had done. And on a neutral canvas, we wanted to create a nice, bright, shining shimmer during day kind of a wrap or a shawl around the building. And this was the first intent picture that we drew up in office, looking at as to what we wanted to do with the metal wrap. And then we moved on to more detailed 3D Max drawings. This is a view of the project right at the beginning. So the intent was that the wrap needed to be a symbol of femininity, because the block itself was very masculine and big, and and made in form finished concrete. We finished it with tessellated zinc cladding, and wrap became the major differentiator in the project. And I will take you through the whole process now of how we went about it. Initially, we had to actually do the 3 or 4 dimension, the 3-dimensional form. We thought that we will use a cellular, form and fuse them in a way that we actually are able to achieve the form. But and the other one was to actually use ferro cement, as well as we explored the possibility of stainless steel but that was too expensive, not feasible. Then we left it at that point. We looked at Gary's Walt Disney project and actually how they did it and how they actually used stitched up all the panels. And that is when we came across the idea of using zinc as a cladding on top. This slide summarizes actually how we did it. The first three are pictures which we drew up in Rhino and SketchUp, and then we actually, there is a secondary steel. What I'll do is I'll also take you through the process in detail, but here it kind of gives you one snapshot of the steel supporting steel structure inside is cladded with MS on steel sheets on the top, and the steel sheet on the top receives the zinc cladding panels. So one of the major challenges that we had was that our studio had actually drawn up the wrap in Rhino as a software, while our consultant, BES consultants, were using another software, and then our vendors were using another software. So there were three different softwares which had to be integrated because all three different vendors were comfortable with different softwares. While we detailed out the form, BES was able to give us the entire supporting structure and to create a wonderful mesh diagram, which you can see below, which and do a lot of experimentation. The initial phases, we didn't realize how difficult it is going to be. We knew the limitations were due to material, but we didn't realize the geometry will cause us that much of trouble. At some point, while we were actually debating between 3 or 4 different options, one was ferrocement, one was stainless steel, the other one was cellular structure. VM Zinc did this wonderful mock-up at their Bandrakula office, which we went to see along with our client, and they actually made it look very simple. So you can actually see the form. This is a mock-up panel which was done right at the beginning of the project. The size of the zinc panels is not correct here. We actually opted for much smaller panels after that. We did around 200 to 225 panels, clip-on joints. And these are the kind of sections which were developed for the skin completely. So every 1 meter of the wrap, we actually had cut sections, and these were in detail so that each layer was visible to the contractor. Our facade consultants came up with the structural design underneath. What you can see are the nodes. There were 4-point, 6-point, and 8-point nodes which were actually designed to have the secondary steel, the primary steel connections to it, and over the primary there was a secondary steel connection, and on that the metal panels came in. So this picture shows you the nodes and the steel joints. This is another wonderful image where you actually see the complexity of what we were trying to achieve. And this was completely fabricated at site because there was no way to make it factory produced piece. And on top of that secondary steel, you can see the MS sheets coming in. And to understand the complexity of the geometry, you can see how complex they were. They were like, turning in both the directions. So we had to be very, very careful with what we were doing, because integrating with the RCC or the building support system was very critical as well. Bhubaneswar, as you know, is a typhoon-prone zone. We had to make sure that it actually is able to withstand the extreme amount of wind pressure. And fortunately, that's one building that didn't have any major damage during the last typhoon last year. To achieve the geometry, that's a secondary steel profile. and on top of it the MS cladding. This picture tells the story in more detail. What you can see it in 3 different stages. On one side are the zinc panels which are already up, but on the other side you see, which is in golden, you see the MS steel being cladded onto the steel, and on that there's a waterproofing layer so that we don't get any water ingress through the wrap, and on top of that are the zinc panels which are getting installed. This was the clip-on system that we had designed so that 2 panels would slide into each other very comfortably, and these were pixelated to around 200 to 250 depending upon the complexity of the geometry. So on the left-hand side you have the covered zinc panels which were installed. On the right-hand side you have it when it was opened up. And it gives a beautiful texture to the whole face because the way light falls on it in different angles, the reflection is different, so we get a nice tapestry of textures on the surface. And that sums up the entire complex mall wrap that you see. To light it up, we worked with AWA, Abhay Wadhwa and Associates from New York. They were our lighting consultants. They decided to light up the mall to wrap only from ground. So there's no electrical point within the wrap itself. It is all lit from the bottom. And there were various different studies that were done to understand the lighting levels. And this is one of the mock-up images that you see, the wrap being lit up from the main canopy being lit up from the ground. And that's one of the passages that gets formed behind the interestingly, you can see the Protective, which is a Reliance retail store shop front on one side and the wrap touching the ground on the other side. Very proud Mr. Negi, he was the project manager who was in charge of the entire wrap, and it took him almost 1.5 years to complete from engineering to installation. And this also gives you a understanding of the scale of the development. Thank you. That's all that I have. This is a night image of the wrap as of today. Thank you.
Thanks, Sandip. It's very interesting. We have architects like you boldly experimenting with unconventional cladding materials. So thank you so much for that interesting presentation. Taking this forward, we'll go a little bit more in depth on zinc. Jonathan Lowy, our next presenter from VM Zinc, will talk a little bit more about using zinc as a building envelope. So Jonathan will speak, and then Sandip, we will have you back at the end. We'll take some questions which have already come. Just out of curiosity, who was the facade contractor on the job?
FAACADE from Baroda.
Oh, okay. Surat, I think, if I'm not mistaken.
Surat, yes.
Surat, right. Okay, great. So Jonathan, over to you.
Hello, can you see my screen? Is that all good?
Yep, perfect.
Excellent. Thank you very much, Sandip. That was a very interesting presentation about the idea of where malls are going, and then about what you did with zinc, which is quite extraordinary. And thank you, WFM Media, for letting me talk a bit more about zinc. So I'm going to run through this quite quickly. There's a lot of slides. This is sort of got a UK flavour to it, but it's also got some Indian projects along the way, so hopefully this will be of interest. So start off with talk about a few subjects, a little bit about zinc, a little bit about the production, the aesthetics, which are obviously very important, and about roofs, build-ups, what you can do on facades, and then some of the more interesting ways that zinc can be installed, perforated facades, and so on. First of all, some of you might recognize that. This might help a little bit more. That's the Arc de Triomphe in Paris. Zinc really took off in the 19th century. It's not a modern material. It's actually got about 200 years of history, mainly in Western Europe. The first project, this church in the middle, was actually roofed in zinc in 1809 in Liège in Belgium. Zinc, get asked this quite often, is it an alloy? Zinc's actually an element, so you can't get any more basic than zinc. Zinc is an element like oxygen or like iron or the other 120 or so elements. It is a metal. The company, WFM Zinc, was actually founded in 1837. It stands for Vieille Montagne, which is Old Mountain, which is where the first mine was. As I said, it's got a long history. In the UK, zinc was used in the 19th century on several railway stations. It was considered then to be something that would be very durable and long-lasting, as it still is. So, how do we produce zinc? Zinc is refined and then hot rolled. So we basically take almost pure zinc, 99.995, we can't really get any purer than that, add a tiny bit of titanium and copper, and I'm talking about sort of 1 kilo per ton, so a very small amount. That just increases the tensile strength of the material. Then it's hot rolled from a liquid into a sheet. That sheet is then rolled down to the thickness that's required for the project and the type of use in question. Zinc's a very sustainable material. It not only lasts a long time, but once it gets taken off the building, it can be recycled very easily. And the actual energy to produce virgin new zinc is very low, or relatively low, compared with metals like copper and aluminium. This is a sort of a case study that we did in Liverpool, in the northwest of England. It's a project that was installed in 1879, a zinc roof. We can't be certain that it was WFM Zinc. It was definitely zinc. And in 130 odd years later, the zinc was starting to struggle. It did need to be replaced, and we replaced it. So that roof lasted 130 or so years. Hopefully, this is good for another 130 years. A little bit about the aesthetics, because that's probably, I'm guessing I'm speaking to quite a lot of architects, and the aesthetics are probably what's very important. Natural zinc is a shiny material, but there are lots of other ways that we can treat zinc and give it a different aesthetic. That's what natural zinc looks like. It's a shiny metal, and when it reacts with water and air, CO2, carbon dioxide in the air, it starts to form a patina, and it performs very well indeed. But you do need to wait. You need a little bit of patience, a few years for the patina to form, and it will form differently on different orientations. So whether the building is the orientation, direction, north, south, east, west facing, the prevailing wind, a roof or a wall, eventually it will be a nice grey patina, but that might take 5, 10, even 15 years for some buildings. And this is what can happen. This is relatively normal for natural zinc. There's nothing wrong with the zinc. It's just slowly forming its patina, which sometimes people find attractive, but generally most, certainly building owners, don't want that. They prefer to have something that's a little bit more uniform. And therefore we can produce quartz zinc, which is basically natural zinc that's been chemically pre-weathered. So you get the nice middle grey from day one. No need to wait 5 or 10 years. Oops, sorry. There's a few examples. It can be used for walls, for roofs, for all types of buildings. There's no limit to where the quartz zinc can be used. Actually, before we produced quartz zinc, we produced Anthro Zinc, which is over 40 years old now, and that's a darker zinc, sort of almost a slate color with sort of a velvet texture, which initially was used for flashings on slate roofs, but over the years it's become something that many architects have embraced for, again, all sorts of uses: walls, roofs, shingles, and many types of buildings as well. More recently, in the last 15 years, we've extended zinc to coloured versions. We were asked by by architects going back a few years, zinc's great, it's grey. Yes, it is, but can you add a little bit of colour? Which we've done and called it the Pigmento range. Now, this is not imitating paint. It's a little bit like looking at zinc through tinted sunglasses. So there's a slight pigment in the pre-weathering, but you can still see the texture of the zinc behind. As I said, it's not imitating paint. And again, this can be mixed and matched, used for roofs and walls. The Pigmento comes in brown, red, green, blue, and a grey colour as well. Here's an example actually in East London where the architect used several of the finishes quite effectively. As I said, grey is actually in the UK now a standard, but we can produce bespoke Pigmento finishes. So if you have a project where you think Pigmento is something that I'd like to consider, but the standard one isn't quite for me, we can look at creating a special colour. And we have done that with sort of an orangey, it's almost a little bit like a Corten type colour or in a yellow. These are not bright colours. They're fairly discreet. And here's an example of Pigmento orange in India, which is I believe the Amani Group, a museum by the Amani Group in Kolkata, using Pigmento orange, which is a bespoke Pigmento finish. Attica was launched a few years ago, and it actually has an engraved texture to it. So the zinc, you can actually feel, and not only see, but feel a texture, which gives it a little bit more depth. And again, this can be used wherever you like. Zinc can be used by the sea. Zinc and salt perform very well. On some surfaces, you can get salt buildup, which doesn't really affect the integrity of the zinc. It can leave some staining if it's on a non-rinse surface. Generally, roofs and walls are fine, but soffits right by the sea need to be considered a little bit before being designed. It's a little bit our train map, our timeline of products. So the roofing systems, traditionally, batten cap was used, which is a timber batten, a U panel between the battens, and then a cap over the top. Those were the rooftops of Paris in the 19th century, and it's still used, and it's a perfectly good system. On the left's a project in London, and on the right, on the French Riviera, I don't know if you recognise this. On the right, Lord's Cricket Ground in London, the old pavilion. The roof was replaced with a zinc roof, mainly because the old lead roof was considered too heavy for the steel structure. Zinc is much lighter than lead, which is one of the advantages. Standing seam is the system that's probably more commonly used and you might be more aware of. So it's a way where the seams are actually all crimped together. Probably a little bit more discreet than the batten cap system. The softness of zinc, the malleability of zinc allows all sorts of shapes to be created. So you can curve zinc quite easily. This is a private residence that was done in standing seam in Longvalor, I believe, and this one on the left is Goa and in Pune, all standing seam roofs, and you can see on the left there the panels have all been tapered to create an elegant curve. The zinc does require, it's not a waterproofing material, it's a weather resistant material, which means that water shouldn't sit on it, which requires a 3-degree slope. So we don't want water ponding on a zinc roof. You want the water to run off. You don't need a very steep slope, but we recommend at least 3 degrees, which is 5%. All the flashings can be produced in zinc. You don't need to use other materials. So whether they be the flashings with other materials or whether it be the gutters and downpipes, all that can be in the same material. Here's some flash inline roof lights, which are quite effective. One in the Pigmento red and the other one in quartz zinc. On the bottom left is the seam. So the seam is crimped, folded over. to create a weather-tight, not a waterproof, a weather-tight joint. So it becomes waterproof when it sits at 3 degrees. And here's some of the tools that the a zinc installer requires, installer stroke fabricator. That's a typical profiling machine. So a coil goes in at one end and out comes a profile at the other end. Slightly close up. Now zinc it's not, I said it's soft. It's not soft like lead. It has very similar characteristics to copper. So if you pick up a sheet of zinc and a sheet of copper, they feel very similar. Obviously one's red, one's grey. Standing seam on a wall obviously works on a roof, also works on a wall, so you can have a continuity of a roof to a wall. We recommend the panels not being too large. If you do a very large panel, flatness can become an issue. And Sandip did talk about strong winds. If you use narrow panels, zinc will resist pretty much anything, and we're going to see a case study of that a little bit later. Here are the clips that are involved for a zinc roof for a wall. You need fixed clips and sliding clips because zinc, like all metal, expands and contracts, and it must be allowed to do so. Some eave details, I'll skip on a little bit, and here's a typical ridge detail. There are different options, different details that can be used, so you don't always have to stick with one detail for one particular area. Little bit about build-ups. Now, build-ups do vary from country to country. Zinc is zinc, but there are different options. In the UK, warm roof build-ups are becoming more popular, where zinc's actually installed directly on insulation, which might be less used in India, but it is an option. What's required in the UK is this needs a combination of products. So it needs the zinc, it needs the right insulation, and it needs a vapor barrier. And when you design a warm roof, every layer could have an influence on another layer. So it has to be designed as a whole as opposed to individual separate layers. These are some of the pegs, some clips and pegs that are used to fix the panel. Obviously, you can't fix directly to the insulation. You need a peg and a screw that go through and fix back to the substrate underneath. That's a cross section of it, and that's an example. Another warm roof build-up. And then we use something called cellular glass, which is insulation which acts as a vapor barrier in itself, which is ideal for things like swimming pools where you have very strong vapor drives. And here are the plates that the actual standing seam clips are fixed to. And another system that's becoming more popular, especially on large, simple projects, are insulated metal panels. So the zinc can be fixed directly to the insulated metal panel, which is fairly quick. So for a large, simple project, it's quite cost effective. Zinc does suffer from something called underside corrosion. That's when you get permanent moisture sitting between the zinc and the substrate, not for a few days or weeks, but for months and years. So that has to be avoided. There are other metals that also suffer from that. So that's about getting the build-up right. But when you get the build-up right, the zinc will last for decades. Little bit on facades. Roofs are a little bit more limited. Facades, you have a lot of choices, a lot of different systems. You can use a standing seam, as we saw earlier. This is a slide. I'm sure everybody's heard about the Grenfell disaster that happened 3 years ago in the UK, where there was a fire, and one of the problems was the cladding. Zinc is non-combustible, so that's not a problem, but sometimes the substrates are not. And on tall buildings, often standing seam is installed over some sort of steel deck to take out the combustibility elements that might have been there, plywood and so on. That's an example of a galvanized steel deck for a non-combustible facade. Standing seam cladding, again, it can be curved as McDonald's. Even McDonald's use zinc. And the standing seams can run vertically, but also horizontally. That's a project on the right that's natural zinc, and you can see it starting to form its patina. It's in a very exposed location, so there the patina will form quicker. And you can even put the zinc at an angle, The one on the project on the right is actually a theatre in London. Looks a little bit like Darth Vader's helmet, but it shows the flexibility of the zinc. And renovation. Obviously, we do a lot of new projects, but renovation is quite popular as well. So re-skinning the facades of old buildings. Here's a project. These are projects in India where Anthro Zinc's been used, and on the right the pigmento. And then this is again in India, where there's a combination of finishes, standing seam at an angle. Flat lock panels, which come under different names, sometimes called shingles, but they're just basically simply hemmed panels, which is what was used on the project that we saw earlier. So they were square or diamonds, but they could be rectangular as well. So these are rectangular panels, which can be vertical or horizontal. You can mix finishes, and you can use diamond patterns equally. Panels can be slightly modified to have, in this case, flat edges. This one on the left is their inline joints as opposed to overlapping joints. Then there's a product called Attica, which is a pre-made shingle, which allows you to have a slightly lower slope on a roof. Shingles, you need to be a little bit careful about making sure that you have a reasonable slope for the water to run off. These Attica shingles, certainly in the UK, can go down to 15 degrees, which is 25%. And there's a project in Attica where they've pigmento brown and quartz has been mixed. Overlapping panels, which sometimes could be called shiplap panels, horizontal panels fixed to cladding rails. And then interlocking panels, which are getting into the rain screen family of zinc panels, which follow the same principle as an aluminium panel. You have a rain screen cassette of sorts fixed to a cladding rail with typically a ventilated cavity behind. And the interlocking panels can run vertically, and on the left you can see the mixing of quartz, anthro and natural, but they can also run horizontally. And on the left you've got the textured asangar, in the middle Anthro zinc, and on the right quartz zinc. And here in India, pigmento brown and quartz zinc. Sine wave or corrugated zinc. Nothing, we haven't invented that, but we're just taking the same corrugated metal that you would do with any other metal and doing it in zinc. Very effective, and it can be perforated in different finishes and even curved. So here you've got curved balconies, which are perforated, corrugated, curved panels. And then various types of rain screen cassettes. This is something we call mosaic. The panels can be in different depths. So you can have a 40 mil, a 60 or a 70 mil panel, which gives, as you can see on the left, texture to your facade. And then composite, which is something that is used around the world, which are the same as ACM, aluminium composite material, 2 sheets of zinc with a composite, with a polyethylene core in the middle. There's some examples around the world, on the left in London, in the middle in the US, and on the right in the Jordans. And here are some Indian examples of zinc composite material. And then you can get into the more complicated customized systems where you're really creating very, very bespoke shapes. Here's a project in Pigmento Brown, a shopping centre, which is using a completely bespoke panel, which has been created for the project in question. And again, creating very interesting forms, which is possible in zinc. And now we're getting to the project we looked at before, which is quite amazing. It's great listening to it earlier. Very, very interesting forms. I think everything's been said. Spectacular. This is a project that's under construction. So here, this is a project in Kolkata, which has got actually lacquered PVDF zinc. The advantage of zinc, obviously, it's very flexible, but it can be lacquered. So you can use zinc and then lacquer it. And this is a rain screen, which is a project that's under construction as well. So here, using a rain screen. And just a quick word on flatness. Different panels will have different flatness. Standing seam will never be perfectly flat. Composite will be far, far flatter. This is composite Stonehenge, which some of you might have heard of. It's about 4,000-year-old stones in the west of England, and they built a visitor centre with a composite ceiling with perforations around the edge, which has sort of allowed the light to sort of shaft through, and the supports are acting a little bit like tree trunks. And then, as there's a couple of the rain screen projects in India, this is a rain screen project in London, where the architects didn't want standing seam. They wanted a flat panel with a drainage channel between each panel. So quite complicated, but doable. And here, some rain screen movable screens. And this is expanded mesh in India, which works very, very well, which I think has sort of become a bit of a speciality in India, expanding zinc and then putting it on a facade. And then quickly on gutters, as mentioned earlier, all the zinc can be used for all the flashings, including gutters, but quite often designers want to incorporate the gutter into the roof rather than having an outboard gutter, which can be done in zinc. Solar panels. Many markets need solar panels fixing to the roofs, and that can be done with clamps quite easily. And ornaments, because of the softness and malleability of zinc and the way it can be soldered, you can create all sorts of ornaments. This is one of Prince Charles' pet projects. It does create quite a lot of debate amongst architects, but it does show how zinc can be used to create ornaments. Those balustrades on the top are all zinc that's been spun. One of the advantages is it's much, much lighter than stone or concrete, and you can create these intricate shapes. And then, as you've seen, we can perforate zinc to all sorts of shapes and forms, and you can even stamp zinc on the right and use zinc as an interior application. Environmental profiles, which we have something called the BRE in the UK, which is used in other countries. Talked about zinc by the sea. Zinc is very, very good by the sea. A little bit of care with soffits. And there are a few materials that are not compatible. So some types of timber, copper and zinc don't get on. They shouldn't be in contact. And then a little word, we have done some testing of panels, which generally revolves around impact testing, water testing, and also obviously wind testing. Unfortunately, our zinc was involved in a hurricane disaster back in 2005, so 15 years ago in New Orleans, where there was Katrina, and there's a number of projects that were installed before, and I had the opportunity to be able to go back afterwards. And on the right is a church in standing seam, and you can see the windows have been blown out and the roof's been peeled off. The zinc itself was absolutely fine. So that really has been hurricane tested. Zinc it's not incredibly exotic. It's something that is available. So that's something you should contact our Indian team to tell you about costings and what can be done and in what time frame. Obviously, we can offer samples, technical drawings, quite a lot of design support. Come and see you to discuss specific projects. VM Zinc's been around for 10 years in India, so and have done over 250 projects across the country. So it's obviously Zinc's got a history of 200 years, but also a history of over 10 years now in India. Here is some contact information. Should you want to contact any of my colleagues, please feel free. And I think now it's time for questions, hopefully.
Right. Thank you, Jonathan, for that interesting presentation on the complete life cycle of zinc, overview of your different solutions. Can I have Sandip back We'll give you a break for 2 minutes. We'll take a couple of questions for Sandip first, and then we'll have questions for you. Right. Okay. I'll get to the questions. Sandip, this is for you. We've got a few questions. Let me. Right. The question from Anand Chavan. From a visual inspection point of view, have you benchmarked it for acceptance level as shade is varying at different angles?
Yeah, so the whole idea was, in fact, we wanted the shade variance because our shape of the wrap itself was, folding 2-dimensionally and 3-dimensionally in different directions. Because the light falls on the textured zinc surface in different angles at different points, we do get shade variations across, and that was a desired effect, Anand. We wanted that to happen, to actually create a nice tapestry of something like an ikat weave on the wrap.
Okay. Right. There's a question from Sanjay Goel. Doesn't your concept of malls change after COVID-19?
It significantly does, although we have not been able to completely understand it at the moment. But what we are doing is we are doing a study internally, and which we will be publishing very soon, as a blog post across different platforms. But yes, the malls will be changing in different ways. The current malls which are there will be short-term changes to them. There will be medium-term changes to mall designing and how malls will be operational. And there will be significant changes to long-term mall design process. The short term are very easy. You can understand that there will be more contactless payments in the malls. It will be more digital.
Right.
The main doors will be contactless, so you will have to go as much as contactless as possible. The hygiene levels will have to go up suddenly in all the malls. All the workers will have to be trained again for hygiene. You don't want your clothes to be touched by different people before you try them on. So all those will change. At design side, there will be a significant, on the long-term design side, there will be significant changes that will publish very, very soon. Yes.
Right. Okay. We'll take a couple of questions for Jonathan. There's a question from Mark Angelo Reyes. You mentioned flatness issue for large panels. What is the largest dimension which you would recommend?
Well, if you're using composites, you can go over a meter, because we can produce sheets which are 1250 millimeters wide. So with the folds, you can get up to 1100 millimeters. That's for zinc composite material. If you're going with just solid zinc without any composite, we can make 1.5 millimeter thick panels, and those are probably about 700 millimeters. If you start getting more than that, flatness becomes an issue, and wind uplift as well. So it could depend a little bit on where the project is. If you're in a high wind uplift zone, it might have to be a little bit narrower. But depending on composite, 1100, solid zinc probably close to 700, and composite 1100.
Right. A couple of questions on this topic. How does zinc panels perform when compared to aluminum composite panels with respect to fire safety?
So you have basically 3 levels of. Well, I'm talking about a European standard. There's A2, which it's all to do with the core. So the aluminium and the zinc are fairly irrelevant because they're not combustible, so it depends with the core. So you can do A2, which is limited combustibility in aluminium. What we've produced has always been B in zinc, and then you have the polythene cores, which are D, E, or even worse, which we've never produced in zinc. So whilst ours has not been A2, which is limited combustibility, it's B. So care, certainly in the UK, care has to be taken for buildings above 18 meters, but it's not, use the Grenfell example as it's not that type of core that was used, but it's down to the core. So it's fairly similar between aluminium and zinc.
Okay. This question is next one is for Sandip by Parvez Salim. Why did you choose zinc and why not aluminium for the cladding?
One was malleability. So we were not able to actually get the same form with the shingles. We were not able to bend them in the same way with aluminium. That was the primary reason that we actually had to go with zinc. Zinc is more flexible compared to aluminium panel that we were able to look at.
Right. And at what time did you decide that you would use zinc as a material, or from day one, from when you designed it, was it always going to be zinc, or from the first drawing you produced?
No, it was not. So we were simultaneously looking at three different options. One was stainless steel. The second one was ferro cement. If we could actually do one singular piece with using ferro cement with a mesh below, and one was zinc. All three were taken up to a comparative statement was made for each one of them, presented to the developer. Cost comparisons were done between them. Technical comparisons were done as to what we could actually implement at site. And at the end, we were convinced that zinc is a better solution for this.
Right. Okay, there's a question from Siva Krishnan. I don't know if you or Jonathan could answer. The zinc panel used on the elevation facade, was any NFPA 285 test done? NFPA 285 is the full screen, is the full system test, I believe so.
Do you want to say anything, Sandip?
Yeah, Jonathan, on NFPA, you will need to take care. I can talk about NBC and maybe the National Fire Code.
I think the 285, that's the US code, I believe.
Right, correct.
I mean, actually the only 285 test that we've done is with composites, because that's the material that's from a fire performance is the weakest. Zinc being non-combustible, and with a substrate in this case, which was steel, being non-combustible, means that whilst the test might not have been done, we would be extremely confident that it wouldn't have any issues at all, because there's really very limited combustible material in that wall buildup.
Right. I think people are confused between zinc composite panels and zinc alone. Your previous answer when you mentioned zinc as being B grade, I think was with respect to zinc composite panels and not zinc itself. If I'm not mistaken, zinc alone is A grade, A1 or A2, right?
Zinc alone is A1. If you put the coatings on it, can turn it into A2 at lowest. But
right.
You're completely correct. Zinc itself is A1.
Right. The reason I asked you this is a lot of people have got confused, and there are several questions asking why is it B, and wanted you to talk a little bit more on the A grade. But anyways, you've clarified that. Okay. The other question is there's a question for standing seam. What is the most acceptable testing standard worldwide for standing seam systems?
The most acceptable, I suppose it depends what you want to test. I mean, generally the concern is about wind uplift. So there are different things. We've done tests in our own internal tests in France. We've done tests in the US. There is a standard in Germany. So that there are a number of, I think it's a difficult thing to say there's a test that would apply worldwide. That would be very nice, but I don't think there's anything quite like that. Different countries will be covered by slightly different tests, but there are a number of tests which show that a standing seam panel, if it's got the correct seam to seam centers and the correct clip centers, will resist almost any climatic situation. Zinc's been installed in Hong Kong and in the Caribbean, where you have typhoons and hurricanes.
Okay, great. Now this one's for you, Sandip. The question is, what were the shortfalls of ferro cement on the building envelope? Why did you decide to not go for it? Was it only cost, or were there other issues?
No, there were two issues. One, we were not able to understand how we will be able to achieve the geometry at the site,
Right.
because it was we were convinced that we will have to achieve the geometry at the site and not at a production or a factory level. So to do that, we were not convinced that we do have the instruments and the technology required to achieve the same geometry. What we were assured was that we will achieve something like what we have drawn, but we will not exactly achieve what we have drawn. So it will not be completely in our control what we get at the end of the day. And the second one was we actually didn't get a vendor who had done a similar scale project in the past. So we were, because time was also a constraint that we had. So we were looking at, somebody, we wanted to be sure that somebody has the experience of actually mobilizing 200, 300 people in Bhubaneswar and would be able to implement a project to this scale.
Right.
That was something that was not done in ferrocement. So what we saw were walls and a good amount of very regular structures, but we didn't see a large amount of large irregular structure in ferrocement in India. Okay.
Another question to you. There's a question from Gaurav Goel. He wanted to know, what software did your facade consultants BES use? Because you mentioned you worked on something, they worked on something else.
Yeah, so BES initial drawings were all prepared in Rhino and CAD. So they were using Rhino and CAD because we started off with Rhino. The trouble came when the vendor started using SketchUp, and we had to actually use SketchUp, Rhino, and CAD in tandem at one stage.
Right.
And for engineering, I'm sure BES was using something else. For the load calculations and everything, they were using something else.
Okay, another question for you. Why were steel sheets required to support the zinc? Why can't it be used on its own?
That's something that I will need Rajan to answer, but I guess the main reason was to actually achieve the form, okay. Because without steel we wouldn't have been able to achieve the same form, because the primary steel was only supporting the secondary form giving steel, and on top of it we had the thin 0.5 mm steel sheets, which also received the vapor barrier and the waterproofing layer. So to receive the waterproofing layer, we needed a material. Also to actually clamp on the zinc, we needed a material in between.
Right.
I could add maybe that zinc doesn't have the same tensile strength as steel. So if on a non-vertical surface, if you try to span between two steel supports directly, the zinc won't deal with that very well. So it's good to have a continuous steel support on an area which is not vertical.
Okay, there's a question for you, Jonathan. Quad zinc one second, let me rephrase this question. Will quad zinc fade with time, or will it retain its original color for a longer period of time?
Quartz zinc really won't change at all. Quartz zinc is a very, very accurate copy of what nature does naturally to natural mill finish zinc. So if you take a piece of, in the vast majority of environments, if you take a piece of quartz zinc today, which has just been milled, and put it next to a facade that was put up 20 or 25 years ago, there'll be hardly any difference at all.
Okay. How often does maintenance required for zinc panels by Nazima Sultana?
The only thing we really recommend is that you let the rain on it. You don't need to go up on a zinc roof or a wall and wash it down. There's no special chemicals or no special products Just the rain coming out of the sky is quite sufficient. It's possible on a roof, if you have a zinc gutter and you're in an area where there's a lot of vegetation, you might want to clean the gutter out to make sure it's not blocked. But the actual zinc panels, whether they be on a roof or a wall, don't need anything other than just rain.
Right. For example, okay, there's another question for pigmento zinc. By how much accuracy in percentage can you achieve the color of different batches per order? You say, let's say I order the same color after 5-10 years. Can you match the 100% color appearance?
That's a good question. When we produce pigmento, there's a number of parameters which can vary. So we do produce it in batches, and we recommend for any one project or for any one facade, let's say, you don't mix batches. So if you have a building, a 4-sided building, and you use 4 different batches for each facade, that would be not a problem. But if you use different batches exactly on the same facades, one next to another, there's a risk that you could see something. It might be fine, but there is a risk. Trying to copy pigmento that was made 5 years ago, today, I have to be honest, that would be quite tricky. It would be difficult to get an exact match. You would get very close, but to have an exact guaranteed match of something that was done 5 years ago would be tricky.
Right. Sandip, this one's for you. Question 1, the retail area and the glazing was getting hidden by the wrap. Was that a concern at any point of time for you? By Manish Kala.
Okay, so there is a very small portion of the retail area which is getting hidden by the wrap. What our design envisaged was that right below the zinc wrap we have glass, and above the zinc wrap we have exposed concrete. So the glass face that you see completely, which I was not able to show in a picture, actually the mall is completely visible at the bottom level. It's a very small portion where the zinc wrap comes down, touches the ground, and goes up again. That's the portion where you actually have the retail behind.
You showed the Reliance store,
and
if I'm
we're
not
aware about it, and I think it created a beautiful space there. It actually is a wonderful space for Reliance store. We in fact, initially told, looking at the drawings, we told them you may not need to do a storefront there, but they insisted on doing a storefront there as well, and it works pretty well for them there.
Right. We'll take 2 last questions. We've got 2 minutes. So this one's for Jonathan. Can zinc be thermoformed on molds to achieve double curvature panels? By Gaurav Goyal.
Zinc can curve in both directions, yes. Depending on the curve or the double curve, it doesn't necessarily need to be done at any sort of temperature. Zinc is relatively flexible. However, it is possible to create a number of ornaments which can be stamped or spun. So it's not really thermo molding as such. It's more stamping, but it's possible on a roof for a dome. The panels, it all depends on the geometry. So the radius, the diameter. If it's very tight, it would be more a stamping process. If it's a little bit larger, it would be just the natural curvability of the zinc.
Okay. Last question, Sandip. There are several questions. What was the average cost per square meter? Including the structure, the steel for the wrap part of the mall.
I will not be able to share that info here at the moment.
Right. Because there were at least 6 or 7 questions regarding the same. I hesitated asking them, but since there were many, I thought let them get the answer from you. Okay.
Yeah, I think overall our facade, because right, we didn't spend anywhere else on the entire facade, and the wrap was the only feature that we had. The overall facade is much cheaper than a normal mall facade. The budget was lower than a normal mall facade.
Right. I think there are many more questions, but we are out of time. 4:45. I think we'll end today here. So thank you so much, Jonathan. Thank you so much, Sandip, for that excellent insight on retail spaces, on the wrap, and overview of Zinc by you, Jonathan. Thank you so much for your time, guys. So just to end today's session. So today's session was recorded, so we will be sharing the video recording with you automatically, which will reach your email 2 hours after the end of this webinar. So you will get an email with the link of today's recording. Our next webinar is on Thursday. That's another interesting topic. That's on fabric facades. Again, a very unique material on how to use fabric on facades. Of course, you would have heard it. You would have seen a lot of tensile applications, but now it's being used on the facade. So that's another innovative material we thought we could present to you guys. We've got architect Dinesh Verma from Bangalore, who's going to be talking on a hotel he did with fabric on the facade. And then we've got Serge Ferrari, French company which manufactures fabric for these kind of applications. So that's on a Thursday. You guys can register at our website, webinars.wfmmedia.com. Thank you all for coming in. A special thank you to you, Jonathan, from the UK, for taking Sandip from Bombay for taking time out. I hope all of us overcome these tough situations soon, and I hope the world resumes normalcy soon so that we all can get into action. And thank you all so much for being there. Jai Hind. Stay home, stay safe, guys. Cheers.
Thank
Many
you.
thanks.
Thank you for.
Thank you.
you.
Bye.
Bye. Bye. Thank you.